The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, good evening. Can you people hear me? Okay, right. All right, so we will start with today's session. Basically, in yesterday's class, you would have started understanding what a function is. So, you might have understood what exactly is a function. So, how do you take care of a function? So, whenever you are trying to do a specific task, you are going to make use of a function. So, actually, we have already discussed about pointers in the previous class. So, pointers are nothing but some special variables which are meant to store the address of another variable. Okay, so that we call it as pointers. So when it comes to the pointers, so these pointers will hold the address of another variable. After storing the address, we have to knock that address in order to fetch the value. Okay. Then we studied about endianness, how the data gets stored in the computer's memory. And also you would have studied about two different types of pointers. One is a null pointer, the other one is a wild pointer. So any uninitialized pointer, we call it as a wild pointer. Dereferencing a wild pointer will always give you undefined behavior. So in order to avoid the undefined behavior of your pointer, then you are going to make use of a null pointer. So null pointer means it's a pointer who is storing the address of null, and the reason why we do it is null is address 0, which is considered to be the most useless yet reserved address of many of the operating systems. So whenever you are trying to dereference address 0, you end up getting a fixed result, which is nothing but segmentation fault, which is better than undefined behavior. So rather than getting undefined behavior, rather than getting your program failed sometime, it is always better to make sure your program is failing for a valid reason. So for that, we are going to make our pointer initialized with null. So that is about the pointers we discussed. And after that, you would have studied about functions. So when it comes to the functions are used to store or write a specific task. Okay, so whenever you are going to write a function, it is to perform a specific task. Okay, so for example, you write any function, it is intended to do one particular task, that is to find the sum of two numbers. So finding the sum of two numbers is a function. It is one specific task. To do it, we write a separate code. So the reasons why we write function is for the sake of reusability, for the purpose of divide and conquer rule, in order to achieve modularity, in order to make your code more understandable and modifiable, in order to make the functions easy to debug and test, and in order to make the function achieve abstraction. Abstraction means hiding. Okay, so that we are going to do it with the help of a function. We took a total view of how a function is written, and we have to study something called as pass by value and pass by reference. So we have two types of functions written. One is pass by value, the other one is pass by reference. Now what happens in pass by value method is, whenever we make a function call, we pass the value of the variables to the function. For example, in this case, I am calling a function called add numbers, and I'm passing num1 and num2. So the value of num1 and num2 will be passed to the add numbers function, which is collected by two other variables called num1 and num2. Okay, you're passing the value. The copy of that value is collected by two other variables, num1 and num2. We perform the operation. After performing the operation, return is mandatory. You have to return the value from the function. After you return, you are going to collect it into a variable and print the value. Please remember, just because you have kept the name same doesn't mean you are accessing the same things. Okay, so you are accessing two different things. So here if you see, we are passing the value of the variable. Now can you help me? What will be the output of this program? So in this case, the output of the program will be 10 and 10 only. So let me make you understand the drawback of pass by value method. So first we are in the main function. Okay. So here inside the main function, I've taken one variable called num1. So this is my num1. The value of num1 here. Okay. So this is our num1. The value of num1 is initially 10. Okay. Now, when I print before modification, if I print the value of num1 before modification, so anyways it is 10 only. Then I am calling the modify function by passing num1. So I am passing the value of the variable. So when the value of num1 is being passed, 10 gets passed. The value of num1 is 10, 10 is passed. Because I have passed 10, when I collect that 10 in the modify function, I collect it into another variable called num1 in the modify function. So here in the modify function, change the name. It makes no difference. Okay. So intentionally we have kept the name as num1 only. But just because I'm keeping the name as num1, I'm not referring to the same variable. So I have passed 10 here. I have collected 10 to a variable called num1 in the modify function. Now in the modify function, when I modify num1 plus 1, this 10 is being modified to 11. Okay, it has been modified to 11. When I come out of the function, I have to continue my rest of the operations. After modification is message printed, then I should print the value of num1. The num1 of main function still remains to be 10 only. Okay, the num1 of the modify function still remains to be 10 only. So that is the drawback of pass by value method of function call. We are passing the value, we collected that value to a copy of that variable. And any changes I made is to the copy, it is to the duplicate. Okay, when I came back, my original variable is unaffected. Now, if I want this to get affected, one thing I have to do is I should return the value of num1. Okay, whatever num1 I have, which is 11, I should return, and I should collect it back to num1 here. So I'm going to collect it back to num1. So num1 equal to, I'm going to collect it back like this. Now please understand another drawback. Using pass by value method, I can return only one value and I can update the return type to integer. As I'm returning something, I'll update the return type to integer. Okay. Understand the drawback of pass by value method. You can make changes to any copy of the variable, but you can return only one value. Okay. Only one value can be returned. Now that is the drawback. I cannot. Now, without returning, I want to make changes to the original variable. Okay, so I'll copy this. Without returning, I want to make changes to the original variable, and that is when we are going to require pass by reference. So now see, this is the program. So here, instead of me calling the function by pass by value, I'm going to call it with pass by reference. Now how do I get the reference of num1? How to get the reference of num1? So we are going to make use of the ampersand operator. Reference means address. Okay. So instead of me passing the value of num1, I will now pass the address of num1. Now see what happens. This is my main function. So here in the main function, I have one local variable called num1. Okay, this is my variable called num1. So this num1 will get 4 bytes of memory allocated as it is one integer. And this is from the address 1000. Num1 has the value 10 stored inside it. Okay. Now when I pass address of num1, I am going to pass 1000. That is the address of num1. Who do you think is capable of receiving the address? What do I need to receive the address here? Previously I was passing the value, I collected into one integer variable. This time I am passing the reference, I am passing the address. Who is capable of receiving that address? It has to be a pointer variable. Okay. Now inside the modify function, So this is our modify function. Here I'm going to have a pointer variable called ptr. So pointer will be storing the address. As it is integer pointer, I will be storing the address of integer. Now pointer gets 4 or 8 bytes depending on the bitness of the system. So this pointer will receive 1000 and pointer points to this location like this. Okay. Now what I should do is, with the help of this pointer, I will directly modify num1. How? It's like this. So I'll write star ptr. Ptr is 1000. Star ptr means I knock that 1000. So I get the value 10. To that, I add 1. Now it becomes 11. Where to write that 11? I should knock the address 1000 and write 11. So I write star ptr here. Okay. Let me explain how this is working. PTR means 1000. Star PTR means knock 1000. Okay. So I'm going to knock 1000. So I'm explaining on the right hand side how PTR plus 1 works. So here it is star PTR plus 1. Knock 1000, then add 1 to it. Okay. So knock 1000, you get 10. 10 plus 1 is 11. You have 11. Now what to do with that 11? Knock 1000 and write that 11. So you will knock the 1000 and change it to 11. Once you come out of the modify function, you can now see num1 has got modified to 11. Okay, num1 is modified to 11. So that is the advantage of pass by reference. So you can pass any number of variables address, you can collect it into any number of pointers, and you can directly modify the original variable. So that we call it as pass by reference. We are passing address of num, we collected it into a pointer, we performed the operation and wrote that value back. So that we call it as pass by reference method of function call. Okay, so here that is I explained. In pass by reference, you pass the address. See, num initially had 10. You will pass its address, you collect it into a pointer. You perform the operation, you directly make change to the variable. So the advantage of pass by reference is you can modify more than one variable's value from a function. In pass by value, what happens is you are going to pass the value of the variable. So whenever you are passing the value of the variable, you are going to perform the operation. So once pass by value is done, you are making change to the copy of the variable. So return is compulsory, but you can return only one value. Okay, but in case of pass by reference, you will have to pass the original variable's reference so that you are making change to the original variable itself. Understood this? Okay. So explain the drawback of pass by value with that code again. So this is pass by value. Okay. So in pass by value, any changes you have made is to the copy of the variable and you have not made any changes to the original variable. So any changes you have made to the copy return is necessary. Okay, so you have to return, you have to collect it into a variable, perform the operation. But in case of pass by reference, return is not necessary. Even without using the return keyword, you will still be able to perform operations. Okay. Now, let me make you understand how to pass an array as an argument to a function. Okay. So next thing is how to pass an array as an argument to a function. Okay. Now, this is our main function. Okay, please understand how this is working. If you understand this, it is so much enough. Okay, this is our main function. Inside the main function, I'm going to take one integer array. Okay, so inside the main function, I'm going to take one integer array called ERR of size 5, return with the value 10, 20, 30, 40, 50. Okay. Now what happens is, this is our main function. So here in the main function, I'm taking one array called ERR of 5 values. 1, 2, 3, 4 and 5. Okay, so this is the name of the array called ERR. So this is from the address 1000, 1004, 1008. Each integer is taking 4 bytes. So 1012, 1016. So like this, I have the array with me, and this array is filled with 5 values. Can you tell me how to access the elements of this array? How to print the elements of this array? So I'm having 10 here, 20 here, 30 here, 40 here, and 50 here. Okay. So every array is going to be accessed with the help of indexing. The first element is in the index 0. Second element is in the index 1. Okay. Third element is in the index 2. Fourth element is in the index 3. And fifth element is in the index 4. Okay. If I have to print, if I have to access the elements, so I'm going to run a loop. Okay, like this. For I is equal to 0, I less than 5, and I plus plus. Okay, I want to access all the elements. I perform something like this. Now what happens is, I'm going to add one printf statement here. %d equivalent of ARR of I. Okay, so I represents the value 0 first. ARR of 0 gives me 10. ARR of 1 gives me 20. ARR of 2 gives me 30. Like this, we printed the elements of the array. But this time, I don't want to print it using the main function, because many times I have to print the elements of the array and I cannot keep writing the logic again and again. Okay, the logic cannot be written again and again. It is waste of time to have the same logic written for multiple times. So what I want to do is, I want to access the elements being inside an other function. Okay, so I want to access the elements being in another function. So I am going to call a function called display. Okay, let me call a function called display. Now to this display function, I will pass the base address of the array. Okay, to the display function, I'm going to pass the address. When I have to pass the array, I just have to pass the starting address because all other elements are continuously sitting one after the other. So I have to pass the starting address of the array. Okay, starting address of the array. Then I have to tell the number of elements inside that array. Do you people know how to get the starting address of the array? Do you people know how to get the starting address of the array? So the starting address of the array can be obtained with just the name of the array, like this. So first line I wrote here is a comment. Okay, I added 2 lines, it's a comment, it will not be executed. I'm calling the display function by passing the name of the array and the size. The starting address of the array, yes, you can either write address of ARR of 0 or you can just write ARR of ARR. That is also enough. Okay, just the name of the array will represent the starting address of the array. Okay, you don't want ampersand of ARR of 0. So you just want the name of the array because it always represents the starting address of the array. Okay, I am passing 1000 here and along with 1000 I am also passing 5. Okay, now I am going to collect it into the display function. Void, I am not going to return anything from the function. So display function. Who is capable of receiving this 1000? Who is capable of receiving this 1000? Yes, this 1000 can be received by a pointer variable, which is an integer pointer. Okay, so the 1000 what you are passing here can be received by one integer variable, integer pointer called ptr. Then I'm going to pass the size, which I'm going to collect it into one integer variable called size. Okay, so I'm just passing the name of the array which represents the base address. I passed 5, I collected into a integer variable. Now I want to print all the elements. So just like what we wrote there, I'm going to take one integer variable called I, and here in this case I used to write ARR of I. ARR is the name of the array representing 1000. Now who is representing 1000 for me in the display function? In the main function we used to write ARR of I, and ARR was representing the address 1000. Now who is representing 1000 for us? It is ptr. So we can write ptr of I. Okay, in order to access the elements, we can write ptr of I. And instead of me running the loop for 5 times, I will run the loop for size number of times. Okay, why to hard code? I know how many elements I have inside the array. I'm going to run for size number of times. Okay, so that is how the pointer is considered. So I'm calling the main function. Okay, I have integer array ARR of size 5 with certain values. I want to access the elements. I'm calling the display function. I pass the starting address and the value 5. 5 is telling I have 5 elements inside my array. So I pass the base address I collected into a pointer. I pass the size. I collect it into one integer variable called size. I'm running the loop. Here to access the array's elements, I would write ARR of I. ARR was actually representing 1000. So it is 1000 of 0, 1000 of 1, 1000 of 2. That is what we used to do. Now the same 1000 is represented by a pointer variable called PTR. So we are writing PTR of I. Okay. So this is functions call. This is functions definition. So when you write the functions call before functions definition, then you have to write one functions prototype. Okay, it is mandatory to write one functions prototype like this. Functions prototype is nothing but the very first line of your function terminated by a semicolon. So that is the shortcut you can remember. Okay. While passing ARR in the main function, it is not addressed right. It is addressed, Harish. As I said, ARR is having a special meaning. The name of the array always represents the address in which the array is found. Okay. So Kalyan Satvik is asking PTR of I can be written as star of PTR plus I. Yes, Kalyan, you can. I don't want to confuse others with that concept, so I'm just keeping it simple. Okay, so that is how we are going to perform the operation. I hope you have understood it. So that is passing array. So here it is actually a pointer. Okay, int ARR is the pointer. Okay, Arvind is asking why ARR and why not ampersand of ARR. Ampersand is not necessary because, as I said, name of the array will represent the starting address. So you don't have to use ampersand again for it. Okay. So Vinay is asking why prototyping, which is specify the arguments type is enough. Yes, you can either specify only arguments type or you can specify that along with arguments name also, which is fine. Okay. So Deepika is asking, why don't we write star of PTR of I? Okay, I'll explain that. What star of PTR of I does. Okay. Now see, what happens is, I'll put this down. Okay. So this is our display function. In the display function, we have two variables. One is a pointer, the other one is a size. So this is our display function. I have two things. One is the pointer, the other one is the size. Okay. So now the pointer, when I pass ARR, please remember this. It is just the name of the array who represents the starting address or the base address of the array. So I am passing ARR, which is the base address or the starting address of the array, 1000. Pointer receives 1000 and your size receives 5. Okay. In the main function, when you write ARR of I, so this used to give you 1000. ARR represents the base address 1000. Internally, it is 1000 of 0. It is 1000 of 1. It is 1000 of 2. It's like this, 1000 of 0. It is 1000 of 1. It is 1000 of 2. Okay, so that is how you did inside the main function. Now, I don't have ARR in the display function. Instead, I have PTR who is representing 1000. So, in order to say 1000 of 0, 1000 of 1, 1000 of 2 in the display function, I should write PTR of 0, PTR of 1, PTR of 2 and so on. Okay, just I'm trying to correlate. PTR is 1000, 1000 of 0. Okay, you will go in 1000, you go index 0, you get 10. From 1000, you go index 1, you get 20. From 1000, you go index 2, you get 30. So it is 1000 of 0, 1000 of 1, 1000 of 2 and so on. Okay. Now what happens if you write star PTR of I is star of 1000 of 0, let's say. So 1000 of 0, this is 1000. 1000 of 0, you already have 10. So you are writing star 10. 1000 of 0 is already giving you 10. So you are writing star 10. Star 10 is wrong. So this gives you segmentation fault. Okay, you should not be doing it. So that is how you are going to perform pass by reference by passing the array as an argument to a function. I hope you people understood this, right? So that is the program here to print the elements of the array. This see it as a pointer. So this is nothing but int star. Okay, so think it as a pointer here. Next one. How to return the array from one function to another. Okay, so how do you return an array from one function to another? Now see what happens. I have an example here. Okay, first this is the main function. So I'll take the main function here first. Okay, I'm explaining the code how this is running. So this is our main function. So in the main function, I'm performing certain operations. Okay, this is my main function. My main function is having an array called array of size 5. This is main function. So this is having array of size 5. Okay, I'll copy this. It is an array of size 5. Okay, then apart from that, I have one integer pointer called IPTR. So this is my integer pointer IPTR. It is ready to store some address. Okay, this is IPTR. It is ready to store some address. Okay, now I am calling the modify array function by passing array and 5. Can you tell me what gets passed here? To the modify function, what gets passed? So when I pass array and 5, array is the name of the array here. Okay, so it is ARR. Array is the name of the array here. So it actually passes 1000 and 5. Okay. Then I collect it into modify array function. So I'm collecting it into modify array function. Now in the modify array function, okay. Now here in the modify array function, I collect it into two things. One is a pointer variable. This is the modify array function. Modify array. That is the name of the function. So in this I'm taking one pointer called array, one integer variable called size. Okay, this is my pointer array. Array, I'm just keeping the name same. Okay, and this is size. Array is a pointer in the modify array function. This is size. So array receives 1000 here, size receives 5 here. Okay, array receives 1000 here and size receives 5 here. After this, I am going to write star array plus I plus equal to 0. Star of array plus I is nothing but array of I. Okay, so instead of me writing it like this, let me tell you, array of I is same as star of array plus I. Okay, array of I is same as star of array plus I. Okay, now what happens here? Instead of this, I'll write it as array of I plus equal to, you already know, I'm going to change it. We have already studied array of I plus equal to 10 means array of I is equal to array of I plus 10. Okay. Now array inside the modify function is representing 1000. So I am writing 1000 of 0. I is 0 plus 10. What is 1000 of 0 giving me? 1000 of 0 gives me a 10. 10 plus 10 is 20. Where to write that 20? It is to array of 0. Means 1000 of 0. This is 1000. 1000 of 0 is changed with 20. Okay. Next. Array is still representing 1000. When it is 1, 1000 of 1 is equal to 1000 of 1 is equal to 1000 of 1 plus 1. So 1000 of 1 is representing me 20 plus 10 here. 20 plus 10 is 30. Where should I write that 30? It is to 1000 of 1. This is 1000. 1000 of 1, I have to change it with 30. Like this will be changed to 40. This will be changed to 50. And this will be changed to 60. Okay, this will be changed to 60. Now I say return array. Array is a pointer. It represents 1000. I return 1000. Okay. 1000 is returned. You collect it into a pointer variable called IPTR. So 1000 is returned here. IPTR receives 1000. Okay. IPTR receives 1000. After this, I am calling the print array function by passing 1000 and 5. So here I am passing 1000 and 5. So 1000 is collected by a pointer. Size receives 5. We are accessing the array's elements. We get 20, 30, 40, 50 to 60 printed. Okay, print array function is just like your display function. It is going to print the elements of my array. Okay, in fact, if you want, I can detail it. Okay, now I come back, I'm in the print array function. So this is the definition of print array function. So this is the print array function. Now what happens in the print array function is, this is our print array function. Inside print array, I have array and size. Okay, this is print array function. Print array function. So inside print array function, I have, let's say, array and size. Okay, so like this we have. So here I'm passing 1000. Okay, I'm passing 1005. So array here receives 1000. Array receives 1000 and size receives 5. So what I'm doing is I'm printing 1000 of 0. Array is 1000. So 1000 of 0, I have a 20. 1000 of 1, I have a 30. 1000 of 2, I have a 40. Then 50, then 60. This is nothing but int star array. Array with an empty braces means int star array. Okay. So I'm passing 1000 here. 1000 of 0, 20 is there. 1000 of 1, 30 is there. 1000 of 1, 40 is there. 1000 of 3, 50 is there. Then 60 is there. So that is how the elements will be printed. The output of this program will be 20, 30, 40, 50 and 60. Okay. So that is how you return the elements of an array. Okay. So that is about the returning array. Let us take a break of 5 minutes. Okay, so let us continue. Um, so some of you are asking for the recorded sessions. So let me quickly take you to that. So first and the foremost thing, to access your recording sessions, you need access to LMS. Okay, so there is a platform called LMS. So that is Learning Management System, which is being handled by uh, us, means the folks of Emertxe. So this is the login page of Emertxe. So maybe when you search for um, Emertxe's LMS, okay, so you will go to this link. So if you want, this link will be shared to you people. Okay. Now the login ID and password will be shared to you people. Okay, through your mails. So in your mails, you will receive your login ID. Login ID will be your mail ID through which you have registered. You will get a password provided. So you are going to provide the password. After you get the password, make sure you check in your spam, you check in your bin. Somewhere you would have received the access to the LMS. Now when you go to the home, you are going to open your course. So there is a course created called Internship, which you are going to open. Okay, so when you open this internship platform, so you will see certain things. One among them is the C module recordings. Okay, so maybe it will be compressed like this. You can expand to see the C module recordings. So as of now, 4 recordings are added. Yesterday's and today's I will upload it by the end of the day. So the recordings will be provided to you. Okay. Okay, Shravani is saying password is your mail password only. Good. Okay, maybe check once. Okay, try with your email ID password only to log in. Then you are going to access the recordings here. So all the recordings along with when was it taken and what topics are covered are being provided here. So you are going to click on it, watch the recordings anytime you want. Okay, tests are not scheduled. Tests should be scheduled, only then you can take it. Coming to the assignments, you just have to keep the program ready for these assignments. Okay, so you should be typing the programs, keep it ready. You don't have to evaluate, you don't have to submit it anywhere. So once you are done, we will give you how to submit it. Okay, so we will give you the way to submit your assignment. Just practice the course, you should be done. Okay, so let us proceed with the next thing, that is how to return an array from one function to another. So about the static keyword. Okay, there is something called as a static keyword which you have to understand here. So in this example, first I'm going to take the main function. Okay, so this is our main function. So here in the main function, okay, this is our main function. So in the main function, there is one variable called uh, array underscore val. It is a pointer variable. Okay, so this is our main function. So here in the main function, we have this is the main function, and in the main function we have one pointer variable taken called array underscore val. So this array underscore val, okay, is having some garbage value initially because it is not initialized. It's a pointer variable and it is meant to store some address, but it is not initialized. So as of now, it is having some garbage value. Then array underscore val is equal to return array. I'm calling a function called return array. So this is the return array function. Okay. Now here I'm going to add the return array function. Now in the return array function, I have one integer array called array of size 5. So this is the function. Listen to me very carefully. This is the function. So inside this function, this is return array function. So this return array function is having an array of size 5. Okay. So like this, it has an array of size 5 provided, and after this, I'm going to say return array. Can you tell me what gets returned from this return array function? What gets returned from this return array function? When I say return array, array is the name of the array which is representing the starting address called 1000. So when I say return array, 1000 is being returned. So as I'm returning 1000 here, I come back to the main function. I am receiving it into a variable called array underscore val. So here 1000 is returned. Okay, I stepped out of the return array function. In the return array function, I created a variable, and when I say return array, it is 1000. As I am returning the address, I have int star here as the return type. So whenever I return the address, I will have a star. I am returning the address of integer, hence the return type is int star. Okay. Then after that, when I come back to the main function, okay, so I am coming back to the main function here. So when I come back to the main function, array underscore val received that value called 1000. Then after that, print array function is being called by passing array underscore val 5. Okay, so print array is called by passing array underscore val and 5. So now what happens? I call the function. So I'll copy it. Okay, now I'm calling the print array function. So this is my print array function. Now in the print array function, okay, this is print array function. So now in the print array function, what happens is I have a pointer variable called array and one integer variable called size. So this is the pointer variable called array. This is the integer variable called size. Okay, so pointer variable called array, integer variable called size. Now what happens is, here I have a pointer variable. When I call the print array function, I am passing array underscore val and 5. Array underscore val is representing 1000. Okay, so 1000 and 5 are being passed. So array in the print array function receives 1000 and size here is going to receive 5. Okay, array receives 1000, size receives 5. Now after this what happens? I am inside the print array function. I am trying to access 1000 of 0. First of all, where is this address 1000? This address 1000 is a part of return array function. Okay, so the address 1000 what you are observing is a part of return array function. So once you have stepped out of the return array function, you cannot access anything from that function. Okay, you cannot access anything from that function. So you are a part of print array function, and here in the print array function you are trying to access address 1000, but address 1000 is a part of return array function. Once you have stepped out, you have no link to the return array function. That function is not allowed to be accessed now. You are trying to access address 1000, which was a part of that function, which is never allowed. So you are illegally trying to access some address which is not allowed. This leads to something called as segmentation fault. Okay, so this program gives you an error called segmentation fault. Let me copy this, put it inside your program to show you the output. So return array dots. Okay, so this is my program. So I'm running the program and this is going to give me segmentation fault. Your program will stop in between. It will not execute successfully. As the program stops in between, you will see an error. It's an error. Okay, nothing will be printed. You get segmentation fault. Okay, I'm compiling. Okay, and I continue to execute. Look at this. Oh, sorry. Okay, sorry. So I should add the functions prototype. Okay, as it is missing, it is giving me an error. Okay, now see, it is giving me an error called segmentation fault. The reason behind that is you are trying to access the memory location which is no longer yours. So when you were a part of return array function, you had the access to address 1000. Once you stepped out of the return array function, you no longer have the access to it. Now being in the print array function, once you have stepped out, you no longer have access to it. So trying to access address 1000 is giving you segmentation fault. Then what is the solution to it is, Whenever you want to access a variable outside the function, such variables are to be declared static. Okay. Whenever your intention is to access a variable outside a function, you have to declare it static. Now, the advantage of static is it stays with you until the program gets terminated. So, there is a special memory section called data segment. Okay. There is a special memory section called data segment. Okay. Now, what happens in that data segment is I'm going to have the memory allocated and it stays until the program gets terminated. Okay. So, memory gets allocated and it stays until the program gets terminated. So, even though you have stepped out of the function, you will still be allowed to access that memory. Now 1000 of 0 gives you 10. For example, I should have 10, 20, 30 here. Okay, 10, 20, 30, 40, 50. So now, even though I'm not a part of that function, I will still be able to access it. Because the memory is not a part of that function, it is available throughout your program. So just observe, adding one static keyword to this will give me the value of the array printed. Okay, so I'm compiling and executing. You can see there is 10, 20, 30, 40, 50 printed. So that is static. Static is a keyword which helps you access the memory until the program gets terminated. So as long as you are a part of that specific program, you will be allowed to access it. So that is static keyword. Without static keyword, you get segmentation fault. With static keyword, you will get the proper result. Do you get this? Okay. Hope you people have got this. Okay. So the next we have is recursive function. Have you people ever heard of recursive function? Do you people know what a recursive function is? Okay. A function calling itself, we call it as a recursive function. Okay. A function calling itself is called as a recursive function. Now the question comes is, why do we have to write a recursive function? Or what is the need of having a recursive function? So please remember, whenever you are writing a loop inside a function, it can be replaced with a recursive function. Okay. So a loop inside a function, anytime you use a loop inside a function, it can be replaced with a recursive function. Need of loop inside a function. Okay. We are going to replace it with a recursive function. Now, let us write a program to find factorial of a number. Okay. So program to find factorial of a number. Okay. Now how to find a factorial of a number? Let's say the number is 5. How do you find the factorial? So let's say I want to find factorial of 5. Okay. Now when I'm supposed to find the factorial of 5, it is recursive, multiplying the numbers from 1 till that number. So that is nothing but factorial. Okay. Factorial of 5 is nothing but 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Or I can say factorial of 5 means 5 multiplied by factorial of 4. So factorial of 4 means 4 multiplied by factorial of 3. Okay. Then factorial of 3 is 3 multiplied by factorial of 2. Something like this. So in need of loop, I can make use of a recursive function. Now see, I will try doing this with the help of normal function. Okay. First inside the main function, I take one integer variable called num, whose factorial needs to be found. Then I take one more variable called fact to receive the factorial value from the function. I call the fact function by passing the value of num because I want to find the factorial of that num. So I am going to call the fact function by passing the value of num. Whatever it returns, factorial function, whatever it returns, I collect it into a variable called fact. Then after this, I am going to print the value of fact. So printf %d equivalent of fact. Okay. Then I am adding one return 0. Now factorial function, this is going to return one integer value, factorial of int n. I am passing num here, which is 5. I am collecting it into a variable called n. To find the factorial, I take one integer variable called fact with the value 1. Then I am going to run a loop for int I is equal to num, I greater than or equal to 1, I plus plus. So I have to multiply till 1. So I am taking greater than or equal to 1. Now what am I doing here is fact is equal to fact multiplied by I. Okay. And then I am going to return the value of fact. So this is how we write a program to find the factorial of a number. Okay. There is a variable called fact. There is a function called factorial return. The function is going to have n received. Whichever factorial we want to find, we are going to write that n. Fact is 1 initially. Okay. I'm starting from I is equal to n, I greater than or equal to 1, I plus plus. Now the initial value of fact is 1. Okay. I'm going to do fact multiplied by I. I is 5. So 5 multiplied by 1 is 5. Fact gets 5. Okay. Yes, sorry. This has to be I minus minus. Then I have to make the value of I as 4. Fact is 5. 5 multiplied by 4 will be 20. Fact becomes 20. Then I becomes 3. 3 multiplied by fact is 20. 20 multiplied by 3 is 60. 60 will be assigned. Then I minus minus will be 2. Then 2, I value is 2, fact is 60. 60 multiplied by 2 is 120. 120 is assigned to fact. Then I becomes 1. So 120 multiplied by 1 is 120. Fact becomes 1. When I value becomes 0, I step out of the for loop. Fact value is 120, that is returned. Fact here receives 120. When I print the value of fact, 120 will be returned. Now, I want to replace the normal iterative function. I don't want to use a loop inside my program. Okay, I value is initialized to n here. So n is receiving the value of num. Okay, I don't want to call this function for I don't want to use the loop. That is when I can make use of a recursive function. Now, how to write a recursive function is, I'm going to replace it like this. See, I will not use any loop. Okay, so here, when the value of n is 1, I have to stop. Factorial of 1 is 1. So I have to stop. If the value of n is equal to 1, I should not be continuing. Okay, so I just have to stop by returning 1. I don't have to continue. Otherwise, what I have to do is, if the number is 5, I want to do 5 multiplied by factorial of 4. If the number is 4, I want to do 4 multiplied by factorial of 3. So I will say return n multiplied by factorial of n minus 1. Okay, if the value of n is 5, I want to do 5 multiplied by factorial of 4. If the value is n is 1, 1 will be returned. If the value of n is 10, I want to do 10 multiplied by factorial of 9. So that is recursive function. You see the factorial function is being called staying inside the factorial function. So that we call it as a recursive function. So a function calling itself is called as a recursive function. So in a program, it calls itself, repeating itself. We call it as a recursive function. But remember, when you are writing a recursive function, two things should be taken care of. One is identifying the base case. The other one is identifying the recursive case. Base case means when to stop the recursion. Recursive case is how long you want the recursion to happen. So this we call it as base case. When n becomes 1, I don't want to continue my recursion. I have to stop it there. That we call it as base case. Otherwise, I want to keep calling the recursive function. So that we call it as recursive case. Now, by any chance, base case is not properly returned, it leads to one more error. Okay, recursive.c, I'm creating a file, and here I'm writing the program. I'm also including the header file. Okay, now see, this is finding the factorial of 5, no doubt. So I'm going to compile recursive.c. No errors, no warnings. I execute. 120, it is printing me. Okay, if you want, I will add one backslash n. So whatever number I pass, its factorial will be found. I pass 6 here. You see, I compile this and execute. I'm getting factorial of 6. Now, by any chance, I do not write this recursive case properly. So let's say I write n equal to 1. Let's say I don't write this only. The base case only I'm not writing properly. Okay, I'm just writing it like this. I did not identify the base case properly. Now that leads to a serious issue. You may not get the proper output. See, I'm compiling and executing. So you can see it is giving me segmentation fault. That is because the program is not properly running according to our expectation. Okay, so when the program is not running according to our expectation, it is trying to do some illegal access of the memory, due to which you are seeing segmentation fault. Okay, when you are writing a recursive function, identifying the recursive case and the base case is mandatory. So this is the example of recursive function. I'm trying to find factorial of 3. So if the number is less than or equal to 1, I'm trying to return 1. When number multiplied by factorial of number minus 1. Do you understand what a recursive function is? Okay. So that is about the recursive function. Here are some of the errors you might see when you are using pointers. One common error we have been seeing is segmentation fault. Okay, so segmentation fault is an error you will see whenever you are doing illegal access of memory. Okay, anytime you are accessing a memory illegally, let's say you are trying to access a memory which is not yours, then that leads to segmentation fault. So in the previous case, I got a segmentation fault because I was accessing address 1000 which is legally not allowed. Here I got a segmentation fault because my memory was not effectively handled. So segmentation fault is the most commonly seen error whenever pointers are used. Okay, so segmentation fault occurs whenever your program attempts to access a memory location that is not allowed to be accessed, or attempts to access a memory location in a way that is not allowed. Here, this is one of an example leading to segmentation fault. Can you identify what can be the reason for segmentation fault? Something is missing here, due to which you might end up seeing segmentation fault. Okay. The reason here for segmentation fault is yes, a missing ampersand. Okay. When you use scanf function, you always have to provide the address where the value should be stored. Now I forgot to provide the address. Num is initially having the value 0. So I am asking my scanf, please read one integer and store in the address 0. Anything you provide that will be treated as address. So you are passing 0 here, it will be treated as address. Your scanf function will read one integer and try storing it in the address 0. That leads to segmentation fault because address 0 is the most useless yet reserved address of any operating system. So you are trying to access address 0, that leads to segmentation fault. You are trying to have a value return in address 0, which leads to segmentation fault. One more reason for segmentation fault here is num is initially having the value 0. Okay, num is a pointer, int star num. So num is a pointer, pointer is having the initial value 0. Now I am writing star num, means star 0. I am telling my computer, please go knock address 0 and get me one integer. Knocking address 0 is not allowed. As I said, 0 is a reserved address for your operating system. You neither can access the value from that address nor you can have any value return in that address. It is illegal. It is a reserved address which is not legally allowed to be accessed. So that we call it as segmentation fault. These are the two common reasons why you will see segmentation fault. One more error is wild pointer. We have already studied. Any uninitialized pointer, we call it as wild pointer. Now, in case of wild pointer, dereferencing a wild pointer directly leads to segmentation fault. Okay, it is undefined behavior. So to avoid the undefined behavior of wild pointer, we have to make use of a null pointer. Any variable declared as static by default gets initialized to 0. So that is not a wild pointer, it becomes a null pointer. Any pointer initialized to 0, it becomes a null pointer. Here it is a wild pointer because the pointer is uninitialized. So that we have already discussed when we were studying about the pointers. Here we have already discussed about null and wild pointer. This is a wild pointer, uninitialized pointer. This is a null pointer. So any pointer declared as static by default becomes a null pointer. So that is about the wild pointer. Okay. So one last we have for today is about const keyword. Have you ever heard of const? What does const mean? What do you mean by const? Okay. Const means something which cannot be modified. Okay. So const is a keyword which tells you cannot modify. Okay. Const means constant. Something which cannot be modified. Okay. Now, for example, I say const int num. Okay. I say const int num. Now, please remember, I cannot modify num at any cost. Okay, num cannot be modified. Number is made constant. Throughout the program, it should remain constant. So it's a keyword which instructs your computer that the value of this variable is constant. Okay, so here num will be made constant. So doing num is equal to 20 is invalid. You cannot do it. Doing num plus plus is also invalid because you are attempting to change the value of num. So const keyword is instructing your system to not modify the value of that variable. Just like that, we have const int star ptr is equal to address of num. Okay. Or if you see here, const star num equal to null. So whenever you try doing star ptr with something, it is not allowed. Okay, let's say ptr is a pointer variable. You are storing null there. Null means address 0. So anytime you try doing star ptr is equal to 20, it is invalid because you have said star ptr is constant. Okay, you write const here only. Okay, you have said star ptr is constant. You cannot change the value of star ptr. It is invalid. You can change the value of ptr but not star ptr. When you write int star const ptr is equal to null, you cannot write ptr is equal to address of num1, something like this. This is also invalid. Okay, so this is again invalid. So int const star ptr is equal to null is here, star ptr is made constant. Any attempts of you trying to change star ptr is invalid. Again in this case, ptr is made constant. Any attempts of you trying to change the ptr value is invalid. It gives you an error. That is const, a simple keyword which instructs the compiler to not modify the value whatever you are specifying. Okay, so that is about the const keyword. There is one last class tomorrow. Okay, so in tomorrow's class, tomorrow will be the last C class. In tomorrow's class, we are going to study about strings and macros. Okay, two things are left. So basics of strings, we will study how to use built-in functions of strings and all. Then about a brief introduction to the storage classes, and we will study about the preprocessor macros. Okay, so these things will be taken forward in tomorrow's class. One last class for C module. From Thursday you will have your microcontroller started. Okay, so do not miss tomorrow's class as strings are necessary for your project. So we will be continuing the rest in tomorrow's class. Okay, so that is it for today. Hope the class is all been clear. Please practice more programs and get ready to start your project soon from Thursday. So tomorrow will be the last C class. Okay. Thanks for attending today's class. We'll continue the class tomorrow. Thank you all, and you can leave. This document, okay, the slide, if you are asking, the slides are there in your LMS, but this document which I'm using to type is not provided anywhere. Okay, I will provide this document once the module gets completed. I will provide this document. Thank you all. You can leave.